Your brand new $1 million modern home is quietly designed to fail. You might have 30 years of mortgage payments left on it, but the cheap metal holding it together will likely never see the end of that loan. My grandfather spent his entire life working with wood. He used to point at those shiny new suburban houses and say they were built to sell, not to live in. He was talking about the lost art of traditional timber framing. When a Category 5 hurricane hits, winds scream past 157 miles per hour. Under that kind of violent, dynamic force, your modern house behaves like a giant sail. The wind slams into the walls, searching for the weakest point. In modern construction, that weak point is almost always a tiny piece of metal. Specifically, standard non-structural 3-inch utility screws. Engineers call this stress concentration. Every single screw acts as a tiny funnel, focusing massive forces onto a single pinpoint. As the house sways, the metal at the neck of these utility screws begins to tire. This is a silent process called metal fatigue. Under extreme stress, some standard non-structural 3-inch utility screws can fail under lateral shear loads of just a few hundred pounds. Then, a sudden snap. One breaks, then another, and the entire wall folds like cardboard. Yet, if you walk through a 200-year-old Amish barn after a massive storm, you will find it standing perfectly still. No steel screws, no metal brackets. Instead of fighting the wind at thousands of tiny stress points, they use timber framing to distribute the load across the entire structure. The building breathes with the storm. It bends, but it does not break. But why did we abandon this virtually indestructible way of building? The answer starts with a silent, invisible enemy that destroys modern homes from the inside out, even when the weather is perfectly calm. It is a quiet self-destruction that begins with the very nails we trust to keep us safe. But the wind is not the only enemy your modern home faces. The real threat is far more insidious, operating in complete silence inside your walls. It is a quiet, physical betrayal that happens even on a warm, sunny day. My uncle, a master carpenter, always told me something I never forgot. He said, drive a steel nail into a beautiful piece of oak and you have just signed its death warrant. At the time, I thought he was just being dramatic, but the laws of thermodynamics prove he was exactly right. It all comes down to a fundamental conflict between two materials that speak entirely different thermal languages. Steel and wood simply do not belong together. Steel is a highly efficient highway for heat. Its thermal conductivity is around 50 watts per meter Kelvin. Wood, on the other hand, is a natural insulator, sitting at just 0.13. This means steel transfers heat nearly 400 times faster than the wood surrounding it. But the real trap is their heat capacity. Iron has a specific heat of just 0.45 joules per gram. It heats up and cools down in an instant. Wood has a heat capacity of 1.7, meaning it holds its temperature stubbornly. When the morning sun hits your house, that metal nail heats up rapidly, but the deep timber around it remains cold. This extreme temperature difference creates a mini climate system inside your wall, a phenomenon known as thermal bridging. And where hot meets cold, physics demands a sacrifice. The metal nail begins to sweat. Tiny, invisible beads of condensation form deep inside the dark, oxygen-deprived pocket of the wood. This moisture has absolutely nowhere to escape. It sits there day after day, slowly waking up dormant mold spores. According to some engineering simulation models, this persistent, localized moisture causes the wood fibers around the metal to decay. These microorganisms begin to feast on the cellulose, which is the very structural spine of the wood. You have probably seen those ugly, dark black stains around nail heads on old fences. That is not just dirt or rust. It is the chemical signature of decaying wood happening right inside the joint. Over time, the wood around the nail turns to mush, and the nail simply slips loose. Your expensive metal fasteners are literally eating the house from the inside out. So how did the Amish build massive structures that last centuries without this self-destruct mechanism? How do you join two massive timbers together tight enough to keep water out without using a single piece of metal? The answer lies in a brilliant, self-tightening joint that actually gets stronger as it ages. To achieve this, traditional builders did something that sounds completely backward.
Modern contractors will tell you to make a joint stronger by wrapping it in heavy steel plates. But the old ways of timber framing do the exact opposite. To make a beam stronger, you carve away a piece of its heart. You cut a hole. This is the mortise and tenon joint. It is an ancient, interlocking puzzle of pure geometry. By carving a projecting tongue on one timber and a matching slot in the other, you create a massive surface area of wood touching wood. This contact creates an incredible amount of static friction. But the real genius is how this shape handles stress. When a violent storm bends a modern house, the wind force concentrates entirely on a thin metal screw. This creates a sharp, destructive shear plane. The screw is forced to resist the entire load on a single tiny pinpoint. But the mortise and tenon joint redirects those massive bending forces. It completely changes the physics of the house. Instead of snapping under a shear load, the wood fibers are put under compression. Specifically, compression along the natural grain. Wood is phenomenally strong when squeezed end to end. In fact, some engineering tests on massive timber joints suggest they can withstand tens of thousands of pounds of force before they even begin to deform. By removing material, you actually distribute the stress smoothly along the natural fibers. It is a beautiful mechanical paradox. Modern building conglomerates want you to buy expensive, high-maintenance steel brackets that rust and fail. They want a system that requires constant repair. But these ancient joints rely entirely on the natural laws of physics to protect themselves. Yet even the most perfect joint has a vulnerability. If a massive storm creates enough suction, it can still pull the tongue right out of the slot. To stop this, the builders used a mind-bending trick of pure geometry. They drilled a hole through the joint to lock it in place. But they did not line the holes up. They deliberately drilled them off-center. If you drill a perfectly straight hole through a timber joint, you are an amateur. Traditional master builders do something that looks like a complete mistake. They purposely make the holes crooked. This is the ancient self-locking secret of draw boring. First, you drill a hole through the outer mortise. Then you drill a second hole through the inner tenon. But you do not line them up. You deliberately offset them by a tiny, precise fraction. Usually this offset is just 1/16 to 1/8 of an inch. When you look through the joint, the path is partially blocked. To lock it, you drive a dry wooden peg, typically carved from tough white oak, into this tight misalignment. As the peg is forced through, it behaves like an elastic wedge. It violently pulls the two pieces of wood together. This action can generate hundreds of pounds of force per square inch. The shoulder of the joint is squeezed so tight that even air struggles to pass. But the real physics happens deep inside the wood. The wooden peg does not stay straight. It actually bends into a subtle, permanent S shape as it snakes through the offset holes. This bend stores elastic potential energy. The joint becomes actively pre-stressed, constantly pulling itself together. It is a living, dynamic connection. Compare this to modern flat-pack furniture. Those cheap metal cam locks and plastic screws start loose and only get looser. They have no memory, no spring, and no life. My grandfather used to tell me something I never forgot. He said a good peg does not just hold wood. It lives with the wood. To make this work, old builders use a clever moisture strategy. They dry the white oak peg to an extreme degree before driving it in, ensuring it is much drier than the surrounding timbers. Once inside, the peg slowly absorbs moisture from the air and the surrounding wood. It swells up, locking itself into the grain forever. But as the decades roll by, this mechanical grip turns into something even deeper. An invisible physical and biological transformation begins. It slowly fuses these separate timbers into a single petrified block. Time is the ultimate destroyer of modern construction. It cracks our concrete, degrades our synthetic adhesives, and rusts our steel. But for a traditional timber frame, time is actually an ally. This is due to a fascinating physical property of wood known as anisotropy. Wood is not a uniform block of plastic. It is a complex bundle of organic fibers that shrink and swell unevenly in different directions. Traditional builders turned this variable movement into a structural masterpiece. They often raised the massive frame using green wood. Green wood is freshly cut, wet, and easy to carve with hand tools. But for the locking pegs, they used white oak dried to the absolute bone. When you drive that bone-dry peg into a wet green beam, you initiate a slow, beautiful molecular dance. This dance plays out over decades. As the wet timber frame naturally loses its moisture to the air, it seeks what scientists call equilibrium moisture content. The green wood dries, and the mortise hole constricts, squeezing inward with immense force. Meanwhile, the dry white oak peg absorbs a tiny fraction of that moisture, swelling outward. The hole shrinks down while the peg expands. This creates a relentless, natural vice grip that only tightens as the years roll by. Eventually, the two pieces of wood lock together so tightly they behave like a single, solid unit. Compare this to a standard metal nail. Steel does not breathe or react to the seasons. When the wood around a metal nail dries and shrinks, it pulls away from the rigid steel. This leaves a tiny, permanent gap. Moisture creeps into this microscopic void, creating a hidden pocket of rust and rot. What was meant to hold the house together slowly begins to destroy it from within. But even a massive timber frame, no matter how perfectly locked, is still vulnerable if it is bolted rigidly to a modern concrete foundation. How did these builders solve the violent clash of forces where the wood meets the earth? Instead of pouring tons of rigid concrete, traditional builders did not bolt their structures to the earth at all. They let them float. They built what is known as a dry stone foundation. There is no concrete, there is no mortar, and there is not a single steel anchor bolt pinning the wood to the stone. When a violent storm strikes, a rigid modern foundation tries to fight the shifting earth, but a dry stone foundation acts like a massive, flexible joint. Under extreme pressure, the heavy stones can slide and rub against each other by mere micrometers. According to one fascinating theory, this tiny movement potentially converts a fraction of the violent kinetic energy of the wind into harmless, microscopic heat. The building sways and dampens the force. It survives where rigid concrete cracks. Then there is the constant threat of water. Because there is no mortar blocking the path, rainwater flows straight through the gaps between the rocks. This keeps the bottom wooden sill plates perfectly dry, preventing the silent rot that ruins modern basements. But what keeps the entire structure from simply blowing away in a hurricane? The answer is pure gravity. The immense dead load of that giant timber frame acts as its own natural anchor. A quick warning is necessary here. Dry-laid stone foundations require master craftsmanship and an immense building weight. Do not try this on modern light-frame homes or the wind will easily blow them away. If these traditional methods are so incredibly durable, you might wonder why we rarely see them today. Why are they so highly regulated and difficult to approve under modern building codes? The answer is not just about safety, but about how our modern world was built. The answer is not necessarily about your safety. Modern building codes heavily prioritize standardized, factory-made industrial products. These materials are easy to test, measure, and regulate in massive quantities. But for traditional, handcrafted timber framing, the approval process has become incredibly complex, strict, and expensive. After all, you cannot trademark a wooden peg. And no corporation can sell you a subscription for a dry stone foundation designed to last centuries. Instead, the modern housing industry thrives on a relentless financial loop. You buy a standard non-structural utility screw, and eventually it rusts. So you buy chemical sprays to treat the rust or plastic wraps to keep out the moisture. Then, when the wood around that metal fastener inevitably rots, you have to buy a whole new beam. My uncle used to laugh at modern blueprints. He called them a subscription model for shelter. With modern homes, you are never truly done paying. How did we get here? During the 20th century, a perfect storm reshaped how we built. Rapid urbanization demanded fast, cheap, cookie-cutter housing to accommodate exploding populations. At the same time, intense lobbying from early concrete and steel trade groups helped establish industrial materials as the legal defaults. These forces combined to push traditional timber framing to the absolute margins. It transformed home building from a self-reliant community craft into a cycle of dependency. To build a house today, you are often forced into a 30-year mortgage just to pay for these short-lived industrial materials. You are locked into the debt, locked into the grid, and locked into a cycle of constant maintenance. But this ancient wisdom never truly disappeared. It is still there, waiting for those who want to reclaim their independence. In fact, there is one final, hidden secret of traditional design that keeps these structures standing even when the earth itself begins to violently shake. And it all starts with a technique that modern engineers are only now beginning to understand. Just remember, these classic concepts are explored through the lens of history and physics. For any real-world project, you must always consult your local building codes and work with a licensed structural engineer. True progress is not about fighting nature. It is about understanding it. We do not need to dominate the wind or the earth with brute force. Instead, we can use simple, brilliant geometry. We can design structures that work with natural forces, neutralizing them from within. This is the philosophy of the flexible joint. It allows for movement. It allows for minor shifts. It accepts that the earth will move, and instead of cracking, the wood simply breathes. When you build this way, you break free. You escape the endless cycle of buying, repairing, and replacing. You choose to build to last. It is a shift from dependency to true self-reliance. It is about reclaiming a piece of quiet power that belongs to you. We have been taught to rely on things that are engineered to wear out, but the oldest wisdom tells us that the best solutions are already all around us. They just require us to look closer. The best home is not the one built with the most expensive materials, but the one that respects natural laws. A quick but very important note. This video explores these concepts through the lens of classical physics and historical mechanics. For any real-world construction, you must always follow your local building codes and work with a licensed structural engineer. But if you think these timber joints are the limit of ancient engineering, there is another level to this story. Across the ocean, ancient builders took this exact concept of flexible geometry to an incredible extreme. They found a way to build wooden pagodas hundreds of feet tall without any deep foundation at all. These massive structures have survived violent earthquakes for over 1,000 years. Instead of fighting the shaking, they are designed to sway like a pendulum using a three-dimensional joint. It is a secret of ancient mechanics that seems almost impossible, but it works. Click on the next video and let us go decode it together.